Now let's continue this. So by the reaction of primary amines with acid chloride, we ultimately have got substituted amides. Fine. Now let me take one example in this case. We have discussed its mechanism. Suppose we have here ethanamine which reacts with acid chloride, that is acetyl chloride, or IUPAC name is ethanoyl chloride. Fine. So again nitrogen will attack this carbon. So the product formed we have here is N substituted amide, which is this, plus NC. Fine. So this N substituted amide is having the name, this is N-ethyl 1,2-ethanamide. Fine. Now one thing very interesting about this reaction, that unlike the previous reaction we have discussed, that is alkylation, which goes on if this is present in excess, but this reaction, though the availability appears on nitrogen, the availability of lone pair is still here, it can further act as a nucleophile, but it has been found it's a very weak nucleophile or a very weak base, which will not further react with acid chloride, and reaction stops at this stage. Let's discuss the cause for this. The substituted amides formed are weaker bases as compared to amines because of delocalization of lone pair present on nitrogen. Now these lone pair present on nitrogen, they are in conjugation with the pi electron of the carbonyl group. As a result, if you observe the resonating structure, then you see here that availability of lone pair on nitrogen is reduced. Here lone pair are present in one structure, but lone pairs are not there in other structure. So this shows that availability of lone pair on the nitrogen is very less. So it makes it a very weak base or a very weak nucleophile, you can say. So the reaction stops at this stage, further it do not take place. Fine. Let me take some more reaction. These are the reaction between the primary amine and acid chloride. Now secondary amines can also react. For example, I have dimethyl amine reacts with acetyl chloride. So nitrogen can act as a nucleophile. Moreover, it have at least one replaceable hydrogen is there. Therefore, the product can be formed, which is in this case is N di-substituted amide, which is N, and in this case it is a dimethyl ethanamide. Fine. So this is a reaction of secondary amine. The acyl group is introduced in this molecule, so the reaction is named as acylation reaction. Fine. Similarly, the reaction can also take place with anhydrides also. Say anhydrides are acid derivatives. So here also you see here nitrogen will attack this carbon, just the byproduct is different. This will go out. The product formed is N-ethyl ethanamide plus acetic acid. For example, in this case you have HCl, here you have acetic acid as the byproduct. So for introducing acyl group in the molecule, you can use acid chloride as well as acid anhydrides. Both of them can be used. Fine. Now, the same reaction can also take place in aromatic amines. but that reaction takes place in the presence of certain bases like pyridine. We'll discuss its reason. For example, we have here aniline reacts with acid chloride in the presence of pyridine. Pyridine is an organic base, fine. So why pyridine is employed here, let's discuss. So here nitrogen again attacks this. Now nitrogen is a weaker base. Here aniline is a weaker base as compared to ethylamine, which we have already discussed, that lone pair are less available on nitrogen. So this reaction is slow in fact. So the product formed in this case will be this plus HCl. Fine. So this is N-phenyl ethanamide. Fine. Now because here this bond, nitrogen carbon bond, is somewhat weaker as compared to if it is alkyl substituted, because the nitrogen electrons are delocalized on both the sides. Here carbonyl group attracts them, but here benzene attracts them. So this bond is not that much stronger as it was stronger when here you had methyl or alkyl groups, right? So being a weaker bond, this reaction have a reversible nature. That is, HCl reacts back, breaks this bond again to give you the reactants back. So for that purpose, you need a base here which will react with HCl and remove HCl, so that reaction remains only in the forward direction. Fine. Then one more reaction we have, that is of the same type, called Schotten-Wommen reaction. Now in this reaction, benzylation takes place. Not only aliphatic acidamides but aromatic can also take part in this reaction, like this is benzoyl chloride. Benzoyl chloride can also react in the presence of a base. Here we use aqueous sodium hydroxide. It again reacts like that. Purpose of sodium hydroxide is same as it is of the pyridine. The product formed you have here phenyl substituted an aromatic amide, that is this plus H. Fine. So very important reaction called Schotten-Wommen reaction. Now in this case, you see the name of the compound is N-phenyl benzamide. N-phenyl benzamide. So this is how acetylation or benzylation takes place in aromatic as well as aliphatic amine. So this is one type of reaction. Now further we'll discuss another type, that is reaction with, next type of reaction we have, it's reaction with aldehydes and ketones. Again a very important reaction. Reactions with aldehydes and ketones. This reaction results into the formation of compounds in general known as azomethynes, also called Schiff's bases or also called anils. Fine. Now let's see how the reaction goes. Here let's suppose primary amines take part in this reaction. They react with the carbonyl groups like this. These can